All right. Hello, you wonderful and brilliant AP Environmental Science students. We're going to be stepping away from specific topics from within the units of AP Environmental Science to look at more of an overarching theme of experimental design and investigation design. The purpose of this particular video is to, one, help you guys think like scientists and kind of understand and do what scientists do in terms of setting up experiments to get valid and reliable results. Now, many of you, of course, are also interested in doing well on AP exams and in-class exams. So you guys will be exposed to some multiple choice questions in which you're asked to interpret experiments or that are described to you. And on FRQ number 1, which is an experimental design FRQ, you might be asked to analyze and evaluate an investigation using APE's concepts and principles, or sometimes you are asked to design an investigation to test a specific testable question or hypothesis, which of course also based on an APE's concept or principle. So in today's video, we have two videos that we will do this in. Today's video is going to cover independent and dependent variables. We'll talk about how to write a testable question and or a hypothesis. So what is essential in the way that we word those? And lastly, we will talk about the importance of a control group. In Experimental Design Essentials number 2, the follow-up video, we will talk about validity, reliability, controlled variables, and a little bit how to interpret data in terms of positive, negative, and no correlation, etc. All right, so let's give some context. So let's pretend I want to set up an experiment because I want to grow better tomato plants in my garden. And I suspect that the problem is my garden soil. So I'm going to set up an experiment. Okay. And if I'm going to get valid and reliable results, I need to test a viable method for improving my tomato plants. So I need to think about what could I change in order to measure its actual impact. Okay. What specifically will I measure? When I say better tomato plants, what do I mean by better tomato plants? How do I objectively record data that says this tomato plant grew better or worse than another tomato plant? Okay, so that brings us to our essential number 1, our independent variable. So if I'm trying to grow better tomato plants, what is something I can change and test in order to measure its impact? That is what's called our independent or manipulated variable. So this is something I actively choose to change. I'm in control of how much that changes by, but that is my essential role. Now, to come up with a good independent or manipulated variable, rule number 1 is I'll only pick one. And this is going to be a star-worthy, exclamation point-worthy point. When we design an investigation, we're going to test how something impacts something else. We only change one thing in that investigation from one trial to the next, and that is our one independent variable. So we're only going to pick one and only one type of change. So my job then is to pick one that I think makes the most sense in my context. So I could test lots of different things on how it might impact the health of my tomato plants. I could test my soil pH. Is it too high? Is it too low? Does my soil need more nitrogen? Or it could be that I think my soil needs more phosphorus instead of more nitrogen. Is my soil texture too fine or too coarse? Is it getting waterlogged or is water draining through too quickly? Which soil amendment is best for my garden? So soil amendments, by the way, are additives I put in the soil. All kinds of potential questions I can ask, but I need to pick one thing to test. I can't try to test and change the nitrogen and the phosphorus and adjust the pH and adjust the soil texture because I don't know which one specifically is giving the results that I'm looking for or not giving the results I'm looking for. I just got to pick one and test just the one. So essential number 2 now is our dependent variable. So this goes back to the question. So when I pick something to change in my soil and I test it, what specifically am I looking for? How am I judging specifically what constitutes better tomato plants or worse. So what am I going to measure? That is my dependent variable. Okay? So how can I measure whether a specific change is having the desired or predicted effect? And that is the dependent, or what we sometimes call a responding variable. So could I measure perhaps how much the plant grows over a given week? Could I measure tomato yield? So for me, that's the ultimate goal. How many tomatoes am I producing? I can maybe judge the quality of the tomatoes, I suppose. But am I getting lots of tomatoes per plant? That seems like it might be a good thing to test, but I could also measure how much the plant grows each week. Lots of potential things we can think. But the thing is, with a dependent or a responding variable, it has to be something I can record and measure, and it has to be helping to answer the question or address the hypothesis I made in the first place. Okay. So now let's get to our testable question, or sometimes we can phrase it as a hypothesis or prediction. So with testable questions and hypotheses, they have to be specific, meaning it identifies what exactly you are testing. So it has to name. So when you write a question or a hypothesis, you name that independent variable, and it needs to be measurable. So it identifies the data that will be measured and recorded. So again, we're going to name the independent variable as well. So anytime we're creating a testable question, anytime we are generating a testable hypothesis, remember, a hypothesis is just a prediction for the testable question, right? In either case, we name both of those items, the independent and dependent variable. It needs to be written in and explicit, the testable question or hypothesis. So for example, a testable question explicitly poses a question of how the independent variable will impact the dependent variable. A hypothesis predicts how the independent variable will impact the dependent variable. Either way, notice we are naming the independent and dependent variables in that hypothesis or question. So if I ask the question, how can I grow better tomato plants, which is something I'm trying to figure out, that's not specific and it's not testable. I didn't name any particular changes. I didn't name what I was going to measure. Okay. So I can shift this once I've given some thought to this question. Which soil amendment, organic fertilizer, chicken manure, or kitchen compost will cause the greatest increase in tomato yield? So notice I'm picking soil amendments, and I'm going to test 3 different types of soil amendments, but I'm just picking one type of change will cause the greatest increase in tomato yield in my parent garden. So this is my dependent variable. This is my independent variable. Now, if I wanted to create a hypothesis for that, I could just make a educated guess or prediction that I think using kitchen compost as a soil amendment will cause the greatest yield in greatest increase in tomato yield. So again, I'm naming the independent variable and I'm naming the dependent variable in that hypothesis, just like I would in a question. Okay, now lastly, and this is probably one of the most commonly tested concepts in experimental design, is what a control group is. Sometimes you're just asked to identify a control group. You might also be asked why we need control groups in the first place. So a control group is an unaltered sample that we use for comparison. So for example, if I am going with my tomato plants, so I'm going to test kitchen compost, organic fertilizer, and chicken manure as soil additives, I would need to have an unaltered sample, which means grow some tomato plants in my soil with no additive there. That would be the control group. So in this case, growing tomato plants without changing anything from how it was done before. Control group is our unaltered sample. We have not applied the independent variable to it. Otherwise, how would I know whether the chicken manure or compost or organic fertilizer are better than nothing at all? One might be better than the others, but maybe nothing at all is the best I can do. We need to have that control group for comparative reasons. Okay, so we have a testable question or hypothesis. We have a control group, we have an experimental group. The experimental group gets that independent variable treatment to it. So we make the change that we've identified, whatever that one particular type of change is. We observe the results for the control group and the experimental group for comparison. And the difference between those results is what we call our dependent variable. That's what we're measuring. So if you would like some other sample questions the College Board has released in and around control groups, you can just ask me. I can help track those down. But for now, you should be able to talk about how to generate a good testable question or hypothesis, differentiate between independent and dependent variables, and you should be able to discuss what control groups are and why they are needed.